Well, hello everyone and welcome to my channel. So today I would like to talk to you about queues. You might or might not have heard about queues, but it's important to note that queues are themselves a very useful data structure in programming. It allows you to add or remove elements in a first in, first out order, more or less referred to as FIFO queues. And what I would like today is to more or less try to expand some of the queues you could work with. And today our language of focus would be Python, and in subsequent times in the near future I will also show you how to work with queues when it comes to Rust, the Rust language, and maybe also of course in Go, depending on what your favorite language is. And so to get us started, like I said, a queue is more or less, you can think of it as a linear data structure. And so we are more or less, we have the possibility to add data in and of course get data out of it, but in a first in, first out order. So the first thing that goes into the queue is also the first thing that leaves the queue. So of course you could use this to, if you can already imagine, in a couple of scenarios where, for example, you would want to do something like scheduling of tasks, and where you put things in the queue and then have another process consume the things that you have put in the queue. And so I would definitely go into details. I'll show you a couple of the type of queues that are in Python, and more or less of course in most programming languages, and then I'll show you some examples, and you could of course hopefully have all you would need actually to work with queues. So without further ado, let's jump right in. So let's jump right in. Like we normally do, I will create a readme over here, readme.markdown. And what I would like to do here is more or less kind of like highlight some of the things we would be talking about today, just so we work in like a more or less a structured fashion. So when it comes to Python, there are a couple of queues that we already have provided. Like I said again, today we would be looking at queues as it pertains to the Python programming language, but more or less of course this is not specific to Python languages. It's just a data structure more or less. So in Python we're going to consider a couple of queues. So here I could say some like types of queues in Python. So the first one would look at would be regular queues, where of course you have the option, like I said, to write in and then write out. And then the next one would look out in Python are called Lifoqueue. So like the names could have already given it away. So for this type of queue, the last one, so it's more or less last in, first out. So it's this, so you can actually think of this type of queue as a stack. So you keep adding things into the queue, and when you get something out of the queue, what you'd be getting out would be the last thing you added into that queue. The next one would look at again would be PriorityQueue. So again, the name again is also more or less self-explanatory. So this is a priority level queue, and elements with the lowest priority are retrieved first. I will again of course show some examples as to how to work with this, and the next thing I would need to show you about would be a DEQUE. So more or less DEQUEs are also queues themselves, but they are double-ended queues. So it means you could add or pop items from both ends of the queue. So you could think of it as it's not FIFO, it's not LIFO, but you just put things in this queue and then you can decide to pop from the first one, or again from the last thing you added into that queue. Pretty straightforward. And of course the next thing I would like to show you, I will try to more or less touch up everything you might, like I always do, need when it comes to working with queues, so you can actually of course use this in your actual projects. You can more or less think about it in scenarios where I think this could be useful. Again, of course I would also give you some scenarios. So what I could say here is use cases. I would show you multiprocessing. Put this way. So I'll show you multiprocessing with queues. I will also show you how to work with threads with queues. And again, like I said, queues you depending on what you're working on, but there are of course already a couple of use cases that you could already think about that this could come in handy. So if you, for example, have asynchronous task queues, you could think of them as, say you have a scenario whereby you have an application, for example, and your users are constantly uploading pictures, and you would want to, for example, process these pictures further. Could be you would want to resize these pictures or edit it or whatever you would want to do. So one thing you could do in this scenario, for example, would be more or less, let's say when the users upload this picture, you put this picture in a block storage, maybe in the cloud or whatever, and then you could actually take the URL to this image and create a task out of it and then put this into the queue. And then you could have another process that pulls tasks out of this queue. So you pulls out a task from this queue, which of course this task will contain the URL of the image that has already been uploaded by a user. So you fetch this item from the block store, then manipulate it and then put it back, something like this. So you have like an asynchronous non-blocking process, because if you say I would want to process the image immediately as they come in, you might again run into a problem that you would not be able to do so, depending, say for example, on traffic. So this is one way this could come in. And again, if you're building an application where you need to schedule jobs, this is of course going to be really handy. If you want to already think about, say, data streaming, traffic, task coordination for parallel processes, and so forth and so on. These are some of the ways you could actually work with queues. So without further ado, let's jump right in so I can show you already how to do this. So one thing I would want to show you first of all is I can create a new file here called main.py, and just for your information, I would list here some of the main operations you could do with queues. So maybe I also put it here in the README. So we can document our code, of course. So I could create a doc string. Maybe I define a main function, for example, and so here I can just maybe add this additional info here just for you. Oh, sorry, it should not be this way. This is Python, Tony. Yes, so like this. So the main, I could also write it out here, so if it's not clear for someone. So the main operations you could perform on the queue, and operations on the queue. So the first one would be, we have on queue. So this more or less is an operation, of course, where you are adding an item to a queue. And the next one would be the queue, which of course would be when you're removing an item from the queue. The next thing would be to check is empty, which is of course like the name sounds, when you want to check if the queue is empty. And then you also have is full. This would tell you, of course, if the queue is full for queues where you've specified like a maximum capacity. So you have the option to specify a capacity or not. And the last thing I would show you, of the last operation, of course, would be pick. So pick gets the item in front, and the queue, more or less the item on the front of the queue, without actually popping it. So one thing you really need to have at the back of your mind is, when you get an item from a queue, it pops that item from the queue. So more or less it deletes it from the queue as you retrieve the task. But pick will show you the item without actually deleting it. So that's the major difference. And what I can do is actually maybe move this here. I can just put it over here, it's fine. And so, or maybe I don't even need this. Yes, I don't think we need it. So I can jump right in and show you some examples. So let's import from queue. From queue we import queue. This is of course from the standard library in Python. And to create a queue, we can call this queue. just like this, and we have a queue. Now again, like I said, you have the option to specify a maximum capacity for the queue. So if we provide a value here, say 100, so it means we can only put 100 items in this queue. Otherwise this would grow and resize depending on what we put inside. And so maybe just to give you an example, I just want to show you a couple of methods that are with the queue. So like again, I said you have empty, full, get not wait, join, blah blah blah, and so on and so on and so forth. We have the option to perform a couple of operations. So you of course you have queue size. For example, you have empty, as you've seen. You have full. Again, you have maybe put, and then of course you have get. And you have of course join. So this one would be when you want to block block the process until all tasks are processed. So if you for example have a scenario whereby you write, let's say you would want to process 100 files, and here we could say max size is 100 for example, and then we can put 100 items into this task, into this queue, and then we have a function processing from this queue. When we use the join method, we basically will block all processes until all 100 tasks that we are put into this queue are processed. So that's just the difference there. And to give an example, maybe I put this back in. No, I don't need the max size for now, so I'll leave it like this. So what I want to do is I'll just take queue.put and I'll put 1, and I can also put another thing, for example, and I put 2, and maybe just to make it interesting, I put 3 items for example. And what I would want to do is maybe over here I'll do queue size. That's one thing we could do. And again, what I might want to do again is to let's say get one thing from this queue. So it's going to get the thing in the front more or less, and then maybe I get another one, and then again I print this size, something like this, and then I open up the terminal, and then I can run, and then we see here. So after putting like 3 items, as you can already see from here, so we put in 1, 2, 3, and then we checked the size, and we saw that the size was 3. And then we did a get, so it gets so like I said, the queues are FIFOs, so the first thing in is also the first thing out. So just for your info again, just to be clear, so this is a FIFO, first in first out. And then we did another get, we got 2, and then we checked the size again, we have 1. There was no need for us to do a pop, because again, just remember, when you get anything out of the queue, you actually pop that item from that queue. And that's more or less what you need to get started with working with queues. Let's look at LIFO queues. So we get this again from the standard library, and so again, like I said, you can think of this as a stack. So I can actually call this a stack when I create one. So I create a LIFO queue. Again, you can specify the max, but I would let you to do that. So I can again do stack.put like we did before, and we'll put 1. Maybe I'll just copy this to speed things up, and here I change this to 2, I change this to 3, and maybe I do a stack.get, or maybe I can actually just print this so you can see it, and I can say let's do the string format, say item. We do it this way. We'll do a stack.get. I'll do another one, and then here maybe I say queue size, for example, and then we log our queue again. Again, you see now the order has been reversed. Initially it was first in first out, but now again this is a LIFO queue, so this here would be last in, would be the first thing that come out of the queue. As simple as that. So the next thing, of course, like I said, would be the priority queue, and I can create one like this, priority queue, and we instantiate it again. Most all of these have the same are more or less implemented in a similar way, as you can see. So you can always specify the maximum item you want to put it in there. So CPQ, if I can type that put, and now of course like I said, the difference with this is that it's a priority queue and it gives you the option to add priority. So, and this I can add in here as a tuple. So I can give this a priority of 3, and maybe the item I want to put, I'll put it in reverse, so it will make sense when we print the items. So I can give this 2, I can make this 1, I can make this B, and I can make this A. Again, now we can print. So it's a PQ, or let's do it like we did before. So format the item, say PQ dot get. So we'll do it this way, a couple of it. Actually, let's print everything, and then we run it again, and then you see, as the name signifies, it's the element with the lowest priority would be printed out first. So that's also why you see here, even though this was the last we put into the queue, because the number has the lowest value in this case, it was printed out first. And of course, the last thing I would want to show you would be a DEQUE. And to use DEQUE, we can get one from collections. So we import our DEQUE this way, and I can define a DEQUE equal to DEQUE like this. So you can already see what the function signature looks like, but it's a little bit similar, because if you hover over this, you would see that what we are to pass more or less should be, and so you can think of this actually as an iterable. So that's why if you want to add item to it, it will more or less do an append. Exactly. So I can append 1, so again 2, 3, and then I can change, of course, this one's 2 and 3. And then a DEQUE is a double-ended queue, so we have the options to do things like what did I do? So you have the options to do things like, instead of append, you can do append left and add a value, whatever. And again, you can, if you want to remove an item from the queue, of course you do a pop. And instead of also just popping, you can also do, as you can already guess, you can also do pop left. So you can add from both ends, and you can pop from both ends. And now what we can also do is just run this and then maybe print our queue. So DEQUE. So what can we get? So let's say count, for example, to see what we still have left. And maybe I can also DEQUE. What else option do we have? Let's see. I think we can actually, because it's an iterable, we can actually iterate over it. Let's say for item in DEQUE, and let's pass. Let me see what this is. Also, this is actually an item, and I can actually print this, for example, and I can say again item, and here I pass item, something like this. And count takes 1 argument, so I can remove this for now. Just I want to see what's left after the pop, and that's actually what we are what we expected. So our queue would actually be 1, 2, 4, 1, 2, 3, more or less. After we did this, and then so we popped the ones at both ends, so 4 and 3, and now we are left with 1 and 2. And that's really it's pretty straightforward. So what we would do next actually is I would show you how you might, for example, want to implement your own queue, so you can understand all these operations I told you a queue normally has. So we can define our own class. I could call it I can't type today, my queue, and I define an init method. And what I would want to do here is to basically initialize my queue. So I can define it this way: self.items. I can provide an empty array, something like this, just to show you more or less what we could do. So I could have a size method, and this size method will simply return, if I can type, the length of self.items. Of course, it has to have to pass in self this way. And what else can we do now? We can implement some of our methods on queue and the queue. So I can have on queue this way, and of course I need to add an item. And now what I need to basically do is self.items.append, something like this, and append the item. And of course what I can also do is the queue, also something more or less similar. So we also do this, the queue, and here we pop. And now of course we don't need to provide any item here, we simply call pop. Yes, hold on. Exactly, so where we can or cannot provide an index, that's totally fine. So, but you can already imagine what error would run into here. So what if we immediately instantiated our queue, we did a pop? Of course this would throw an error because there is really nothing in the queue. So what we can already do is we'll say something like if self.items, oh no, we already have a size method, so we can more or less call it. So say if self.size is equal to 0. So if it is an empty queue, we can return none. So that's I would leave you to. So maybe we can maybe define. I would maybe just implement the empty method, and then you can actually do the rest. As you can already see, it's actually quite empty, so it's quite easy. Empty. So what we need to do here, so this would return a boolean. So here would return, we can use shorthand to say self.size is equal to 0. So if it is empty, of course this will return true, otherwise this will return false. So to use this, what we can already do is say queue is equal to my what is happening to my keyboard, my queue. And now what we can do, like we did before, is print that size and to see what's actually going on, and it says 0. And then what we can also do is empty, and it says true. And now what we can do is DEQUE like we did before. So we add a 1, we add couple, so we can add 2, add 3, and we run this again. DEQUE takes 1, 2, we're giving, let's see, DEQUE, oh, so sorry, should have been on queue. Sorry, my bad, because we are trying to add things to our queue. And now it says it's no longer empty. And what we can also do, like we did before, was say item, and we can see over here, we say queue, that's DEQUE, something like this. Let's see if that works. So what's happened? Item is none. If it's 0, return none. Oh, this is actually not returning anything. So what I can actually yes, let's return. So we see what we are returning. And now we see what we popped. And if we maybe run this a couple of times, because we have added 3 things, and we can see this happen this way. And so this is our own queue. As you can see, more or less, again, as you can imagine, this is more or less trying to cast a light over like what you basically would need when it comes to working with queues. Pretty straightforward.